Welcome everyone, thank you for joining this. So my name is Anthony, and I'm a product manager on Lakeflow Jobs. I'll sort of introduce what all that means in a little bit. And I'm joined by Prashant, who's our resident guru of Lakeflow Jobs. And I just want to kind of level set the stage a little bit before we kind of get into this. In this talk, we sort of assume a little bit about you guys. So if you guys are already sort of aware of what orchestration is on at least a general level, you've already maybe built some simple workflows, whether or not it's with Databricks or with Airflow or ADF or anything else. And you generally have a kind of high-level awareness on orchestration. If your primary goal with your orchestration is to build incredibly reliable, efficient, robust, and cost-efficient pipelines, this is the right talk for you. You want to empower your data teams, potentially either a small company or a large company, potentially scaling, and you're growing your data teams across multiple regions or even across multiple continents. This will be the talk for you. And by the end of this talk, we have a few sort of expected outcomes here. The first one we target is called data triggers. And what we really want to make sure we distill to you by the end of this talk is you're able to leverage these data triggers to really have your jobs run only when the data is ready. You'll be able to use control flow tasks like looping, conditionals, backfills, or parameters to just make your jobs much more robust. And then finally as well, we hope that by the end of this talk you're able to, honestly, if not build complex orchestrated workflows, continue to build with Databricks, and build larger dependency graphs between everything. So with that said, I'm guessing you've seen this in all of the talks so far. We're among friends here. Some of the stuff we're going to say is looking into the future and legally required to say that all this stuff is subject to change. However, we'll be as accurate as we can with the information that we know right now. So the core concept here is Lakeflow. And the big question that I'm sure you're asking right now is what actually is Lakeflow? There's a big keynote that we're having tomorrow that'll explain it in much more detail. However, I just really want to touch on it now. And what it really is sort of unified data engineering on the Databricks platform. So it's comprised of three components, three pillars that span the entire life cycle of ETL. And the first step in any ETL is ingest. And for data ingestion, we have Lakeflow Connect. Maybe I'll be able to point here. Lakeflow Connect, which are built-in, out-of-the-box ingestion connectors from sauce as well as database sources. I won't go into too much detail on these, but I'm more than happy to take any questions afterwards. So after you bring in all of your data into Databricks, the next step is, of course, transforming all of this data, whether or not it's cleaning, normalizing, aggregating. And for this, we have Lakeflow pipelines, which are reliable data pipelines, essentially made simple. We had some talks already on authoring. I hope you guys were able to see some of them. But this is hyper-efficient, incremental, low TCO data transformation within Databricks. And then finally, all of this stuff wrapped together gets orchestrated inside of a job. And a job really is, to use a Prince term, the artist formerly known as Databricks workflows. So the term that I'll be using today exclusively is Lakeflow Jobs. And what this is the next evolution of Databricks workflows. And of course, all of this is built on unified governance with Unity Catalog, as well as hyper-optimized storage that we support natively. So as I said, we're going to focus today on the jobs portion of it, what used to be called Databricks workflows. And what jobs essentially is the sort of unified orchestrator across the Databricks intelligence platform. TLDR, simple authoring, whether or not you want to author your jobs in the UI, or if you're a bit more of a power user and you want to author, manage, observe all of this programmatically. We also provide a suite of a full-spec API, as well as CLI connections and deployments, which we'll go into a little bit later. Actionable insights with onboard metrics, monitoring, and observability. And then finally, proven reliability. 99.95% uptime. So you can be confident that with us, you won't have to deal with any sort of downtime or unexpected failures like that. So within jobs, within Lakeflow Jobs, you're able to orchestrate anything. But what we provide are sort of a suite of out-of-the-box tools to essentially help you along the way to make it easier for you. And these tools, they're called tasks. And jobs are comprised of one or more of these tasks. And these tasks are individual units of work that do something. whether or not you want to do something relatively simple with Databricks notebooks, do transformations with pipelines, or if you want to connect to external tools, such as run your dbt models, or update your Power BI dashboards, all of this can be orchestrated within Lakeflow Jobs. Once you decide the tasks that you want to do, once you decide what your job wants to do, this is where you connect them. You integrate all your tasks together into specific patterns. And these patterns is called control flow. And whether or not you want to do simple sequential execution, we also support out-of-the-box features to support looping, job modularity, or as well as introducing conditional logic into your jobs. All of this is possible using the onboard features within Lakeflow Jobs. And then finally, once you create your tasks, you create your control flow, you need to decide how is this job actually going to execute? How am I going to run it? And we also provide out-of-the-box features to support this. Whether or not you want to have your job scheduled, for example, run every day or every week at Monday at 8 a.m., that's possible. Or if you want your jobs to be a little bit more data aware, and you only want your jobs to run when the data is actually ready, and this will be sort of the main focus of this talk here. So then once you have all this, we kind of level set here. Now I would just want to go in and introduce some of the out-of-the-box control flow features that we have within Lakeflow Jobs. And then afterwards, then Prashant will give us a really cool demo just to kind of show you how this actually all kind of works in practice. So one of the big comments or concerns that we heard from customers previously was that their jobs are just getting really big, really repetitive, really large. They're using notebooks, maybe they ingest some data from GDBC connections, or maybe they process regional sales data that is delineated by country. It's getting very repetitive. And so with that, we built something called for each. And what for each does, it allows looping over a single task with looping for multiple tasks coming soon. Definitely let us know if you need that. We always really like hearing from you guys. And the real sort of value add of for each is simplification and streamlining. So this specific job, we had a customer where they were doing processing of individual tables that were delineated by country, the exact same logic. But they were able to functionally simplify their DAG into what was, I'm not going to count that many tasks, into 4 tasks using for each. For each supports up to 1,000 iterations, with up to 100 of these iterations happening at the same time, so a concurrency of 100. So for each is really cool. You guys should really, really try it out. And of course, it's not just words. We've had customers of all sizes have success with for each in their own control flow, specifically MasterCard, which is one sort of outspoken customer. And if you want to learn more about how MasterCard both used for each as well as Lakeflow Jobs to simplify their orchestration, they're giving a talk later today where they'll speak about one of their specific use cases that we know of. So definitely check that out if you guys have time. So then when you're developing your jobs, or you're debugging your jobs, oftentimes you need to fix individual tasks. And one of the concerns that we heard from customers previously is that they had to clone their job, remove all the tasks that they didn't want, test the fix in an isolated environment, and then port the fix back to the previous job. It just was quite inefficient. So with this, you're able to also run only the tasks that you want inside of your Lakeflow job. So you don't need to worry about running compute for an entire job if you only have one specific task or a subset of tasks that you want to run. You're able to select the individual tasks that you want to run and then run that. So this is quite useful if you want to save time when you're debugging, iteratively develop, and save money because you don't need to run your compute on the entire job. You can only run it on the tasks that you want. Moving a bit forward, I spoke earlier about conditionals. And this is if you want to introduce branching into your jobs. What conditionals support are you can define a specific Boolean logic inside of your conditional task. If evaluated to true, one task will run. If evaluated to false, then another task will run after that. One of the specific use cases that we've seen customers be successful here is for AI training. Within Databricks, within Lakeflow Jobs now, we support the training of AI models natively. And oftentimes you only want your models to actually start training if the data is either of high enough quality or there's enough data for there to be an effective training of that. So with the conditional task, you're able to introduce branching And it's also possible to cascade these if-else conditions by pairing them together for a little bit more granular control if you're looking for that. Moving a bit forward, this is one of our current preview features we would love for you guys to try. It's also a common thing where data arrives late. And data arrives late, you need to process it, you need to make sure that it's reflected in your most up-to-date tables. However, you want to do this easily and robustly without needing a lot of manual intervention. Currently in preview, we have a backfills feature where you're able to trigger multiple job runs over a defined period of time that you could see on the short visual here. And you're also able to do this concurrently. So if you need to do multiple runs over a large period of time, we also support concurrency of 100 parallel runs. GA is coming fast, but if you guys want to try this out before we GA, we'd also love to hear from you and enable your specific workspaces to try it out. So I just kind of give a brief overview of some of the control flow features that we have. So now we've established our control flow. We have our tasks, we have our flow. Now we need to decide, okay, how do we actually trigger these jobs? Do we want it to run every day at 8 a.m.? Do we want to have it run when a specific table is updated? What's the sort of relationship between the data and the job itself? This is where we have with triggers. So the sort of easiest way to automate this is using a schedule, as I mentioned. Let's say you can run it just every day at 8 a.m. With our schedule, we support very simple authoring in the UI. Or if you want to be a bit more precise, then you can also use cron expressions. However, even though this is quite useful for batch processing of batch data, this also sort of starts to become a bit problematic once either your data is late or if the data does not arrive at all. If your data is late and you have a schedule on it, the job may fail. The job may process an incomplete data set, pushing an incomplete data set downstream, or it may just run and not process any data. You have no guarantee of the freshness of your data and the latency between the data arriving and the job actually starting. You have no control over that. So with this in mind, this is where data triggers come into play. So just sort of imagining a scenario where, let's say in the case of file arrival triggers here on the bottom, you have some files that arrive in an S3 bucket. And you kind of have a general idea, you kind of know when the files will arrive, but you don't know exactly when it'll arrive. You have a schedule set on it, but sometimes the schedule doesn't reflect the true state of the data. And what we'll support with file arrival triggers is we will watch these external storage locations for you, and we will trigger the jobs only when the data is ready, only when the data arrives in this specific storage bucket at no extra cost to you. So not only this is a big efficiency boost, the job only runs when the data is ready, it's also a big time save. You don't need to worry about the maintenance and the overhead of dealing with late arriving data. And 3, it's also a big cost save. You can be confident that your job will only run when it actually has data to compute and process. If we move a bit further on this, here we have table update triggers, which is kind of similar in concept to the file arrival trigger, except instead of watching an external storage location, it watches individual tables. So for this, you can say, okay, this job, I only want it to run when tables X, Y, and Z are updated. This is now fully possible with Lakeflow Jobs, and we're very, very close to GAing it as well. Current table types supported are delta tables and materialized views, and we're hard at work making sure that we also support streaming tables and views as well to be able to trigger your jobs. So data triggers are functionally the answer to data latency issues, data freshness issues, if what you want is for your job to run only when the data is ready, then here we recommend to use data triggers instead of schedules. And so I just kind of give a bit of an overview on the technical benefits of it, but in terms of the enterprise or business value add that data triggers have, what they really do is support and empower cross-team collaboration. As your businesses scale, oftentimes your data teams will also scale and become more distributed, potentially across offices, across regions, or across continents. And it's really difficult to keep track of who owns what set of data, who owns what table, who updated table X. I need to know that, so I have permission to run table. So I know permission to update table Y. And with data triggers, it does not matter who updated the table. It does not matter the source of the update. The only thing that mattered is that the data is the most up to date. So if your goal is to empower your teams to build a bit more of a data mesh, a bit more distributed, then data triggers are fantastic for that. Secondly, and I speak about this a lot because this is really important, it really ensures data freshness. You want your jobs to process the latest data. You don't want it to process old data, or you want to make sure that it runs the most up-to-date data. With cron or with schedules, they're not always synchronized to the arrival or the update of the data that the job is processing. But with data triggers, you know that the job will run once the data is ready and it's complete to go. And then finally, it always comes down to cost at the end of the day. With data triggers, we monitor external storage locations, or we monitor the update of tables at no extra cost to you. In your Databricks bill, there will be no extra cost associated with data triggers. So you can be quite confident that compute is not wasted, and your cluster is only engaged once it actually has work to do, once it actually is ready to process some data. So now the whole sort of question here is, okay, this is awesome, this is cool, whatever, but how can I actually sort of deploy all of this together? What if I have hundreds of jobs that I need to manage? What if I have more? And this is where Databricks Asset Bundles come into play. With Databricks Asset Bundles, it essentially introduces software engineering best practices, CI/CD, into defining your jobs. We had some talks earlier about DAGs, and we'll have some more after as well. You guys should check that out if you're interested. Core TLDR with Databricks Asset Bundles, software engineering best practices, version control, and CI/CD in the deployment of your Lakeflow jobs. And the question that we also often heard was, okay, again, cool, but I prefer Python. Maybe I come from Airflow. Maybe I'm just have a bit more of a programmatic background. I prefer Python. And we currently have an active public preview for Python support for Databricks Asset Bundles. So definitely check that out, and definitely let us know what you think of it as we move towards GAing it. So then I'm done talking. I think it's time to actually show how this all kind of looks in practice.
Thanks. Thanks, Anthony. So we'll start with the basics of what workflows are Lakeflow jobs right now. So this is a typical workflow page. If you are already used to Databricks platform, this is the page which you land when you go into workflows. Right now, with a recent change, it is jobs and pipelines. And you click on create job. That's when you will be creating the job for your particular use case. Now, there are multiple ways of looking at this. Like you have, say for example, you have some specific notebook task, for example. Now, we can start with a notebook task here, or we can also see all the available tasks. For example, just showcasing all of them, there are a huge number of task types. Right from what Anthony was discussing, there is notebook task, there is a pipeline, and a huge number of list of tasks, right, including AI dashboard, for example. So these are the various task types. I mean, some of them I'll be showcasing now, like if-else condition being one. This is if-else condition where you can do if-else condition and also continue with the task type tasks which you want to run as part of your pipeline. And there is for each task type as well. So these are the various task types you see in Databricks, and we are continuously adding more. Like very recently, Power BI is another task type which was added to the task types here. And there are a couple of other things, like probably most of you are already using Databricks workflows, but just to give a TLDR, there are a couple of things which you should be doing. For example, adding tags for your specific projects or the teams or whatever is the case. We should be adding specific tags so that those tags are available in system tables and easily cost attribution can be done. I mean, this is more like a general best practice you should be doing. And job notifications, again, if there are failures or if the job is running a longer time, like you can specify metrics. So all these are part of a workflow. Now coming to the point of most important one, this is schedule and triggers, which Anthony was explaining in detail. So there is multiple ways of scheduling jobs. The first one being scheduled, which is where you specify the schedule type. There is simple and there is advanced. Now, this is advanced. You can specify exact date and time, etc. And if you are even more interested, probably you can even use Quartz cron syntax, and you can specify the values here, right here. So this is the normal way of specifying trigger type. Now, if I go to the same trigger type, there are multiple ways of doing this here again. So there is file level trigger, implies there is some ADLS bucket, ADLS Gen 2 bucket or S3 bucket or Google Cloud bucket, where there are files landing. Only when a file lands, you want a file or multiple files land into that bucket, you want this workflow to trigger. So that's when you choose this one. Like you specify file level trigger and specify the storage location. Databricks will continuously look at that folder and trigger this pipeline a moment a file lands into this location. Now, extending that topic a bit more is table update trigger. And it's not just a single table, it could be multiple tables. And you also have an option of triggering when all the tables are updated or at least one of them is updated. So this is again another variation of triggers. So to showcase all this, I do have a simple job which I will showcase now. Yeah. So this is a job which I have been running for quite some time. Let me close this. Yeah. So this is the complete job where I do some analysis with for each. Like for example, I have a lot of data, fact tables in 3 different tables, and I would like to load the data. Previously, I would have to do 3 separate tasks for that, but because of for each, so I'm showcasing the for each task here. And there is the inner notebook, the notebook which actually loads the data. And you can run with for each. So there is the task type called for each, and you specify, I mean, this could be inputs, could as well be, here I have hard-coded, but you can as well get them from an upstream task as also, and use those values which are coming from there to process the data which is there in some specific tables. I mean, I'm just giving one example, but basically for each works this way. And then I have a big DAG doing a lot of bronze, silver, gold aggregations, basically Medallion architecture, and then a bit of machine learning and also updating or refreshing a BI dashboard. So I'm doing all this. At the end of the day, what I'm trying to do is getting product recommendations for a specific, say, in some specific area, all of a sudden a product has become a rage. So we need to ensure the supply chain management and the people who are supplying that should have enough information that that product has to be stocked in that particular stores, for a simple example. So this is how the use case is. And only if it is on a Sunday, I would like to refresh my model. So I would like to retrain my model. So in that case, I mean, there is a simple condition here. Here, I'm using Databricks template here, basically job start time dot and ISO weekday. And if it is Sunday, which is 7, only then I do retrain the model, or else I usually go into the publish model stat. So that's the full view of what exactly is happening in this. Now, this if-else condition is not just on some specific template, but it could also be the task values which are set by any of the upstream tasks here. And I also am doing something very nifty here. So in this case, I would like to run cleanup and log if any of the upstream tasks fail. So you specify here. So there are, again, run if dependencies. So this is a huge tag. Now, probably it might be the case that some task fail all of a sudden, but I would like to clean up, essentially. In that case, I would go specify at least one failed. And by default, it is always all succeeded. In this case, I want to run this task only if one of the upstream tasks fail. So this is how you run a complete pipeline and various number of task types we are talking about here. Now, one cool thing I would like to show here is I'm not just orchestrating the notebook task or SQL files or Python, but I am also orchestrating a DLT pipeline. Now, this is the DLT pipeline, which is actually doing the gold aggregations in this case. So you get, you are able to, as I mentioned before, like we have a huge number of task types which we are able to orchestrate. In that, I'm also showcasing DLT. Now, the cool thing here is I am doing table update triggers. In this case, it's just one single table, but essentially you get the picture, like you can add multiple tables, etc. Now to show this live, I will go to my workspace. I have a simple simulate trigger, which I will run it now. It's taking a bit of time, but essentially you get the gist. So there is a trigger. There is a catalog, database, and the table, product request table. Now I will quickly go to the product request table and run it. 1 second. So this is my simulate table triggers. So I have a database and I have a couple of tables in that, and a particular table I am trying to update, and I'm going to use serverless for this. I don't want to wait for a cluster to start up. So this is a simple statement to trigger the pipeline. So as of now, if I go back to my page, it was run twice till now, and one of them was manual. So let me kickstart the run. Let me run it here. So what this is doing is, this is inserting a record into the table, very table, what we are trying to use as a table update trigger here. So the moment the table is updated, a new record is inserted, it should trigger the job, this particular pipeline immediately. So we'll just wait for the job to this notebook shell to execute, and in the meantime, that job will get triggered automatically. So we'll wait for a couple of seconds, probably, hopefully it will be up. Yeah, it's already executing, so let it run. Executed, so we should see a new row here, a line item, line item, which says it should be launched by a table update, and it's specific run. Like you can already see the job has already come. So this is the by table update. So I inserted a row into a table. That table was being used for triggering this pipeline. So immediately the job started running, and it may take around 3 minutes. So essentially, this is how you can use table update triggers for seamlessly ensuring that you're using a particular table, and based on that table, or any number of tables for that matter, run the pipeline automatically. So this is my first demo which I wanted to showcase. There is another use case where a lot of times we usually need some kind of how should I put it? Some kind of what we want to do is, like, I have a job which is running for quite some time, and all of a sudden it failed in production, for a simple example. So in this case, I have 5 tasks, and we'll just go to one of the tasks and inject an error. So this is where I want to showcase repair and rerun. Now, in this repair and rerun, I'm explicitly injecting an error in my code, in my notebook, a syntax error. If it loads soon. What I'm trying to showcase here is when a job fails, which I was trying to run multiple times today. When a job fails, we automatically, I injected an error explicitly in this code, and let me run this job now. And the moment it reaches this specific task, it should fail because of the obvious reason that I am explicitly injecting an error here. Now, previously, it would have been a pain, like you would have to fix the issue and then rerun the entire pipeline, which is not just inefficient, but also it will incur some costs also. So now what repair and rerun does is, you can start exactly at the point of where that particular job failed. But from that task onwards, you can run as many tasks as possible. Like if there is a dependency that you want to run only specific task, even we can do that. That's called partial runs. So I will show that also. Right now, this job is running, so it should fail anytime now because I explicitly injected an error. Yeah, let it fail. The moment it fails, probably we can go back and fix it. So it failed already. Now, the beauty here is I will fix this error for whatever reason, and then go back to my notebook and do a repair run. So this is where the UI comes, and it also shows you how many tasks it is going to repair. So in this case, I have repair run of 3 tasks because my silver in the silver layer failed. In this case, I have 2 other gold tables, gold notebooks, which are running. But essentially, this is how you run it. And also, you can specify, if I want to run my entire job, you can do that as well. And for example, again, I want to explicitly run only specific tasks, even you can do that. Like in this case, I can select any specific task which I want to run, not just the failed ones, but also the ones which were successful also. So you can do it all this, and you can also specify repair run and then click on, and also specify any parameters which you want to pass. And you click on repair run. The job will start exactly from the point. In this case, I explicitly chose a successful job also, so a successful task also. So it will start from bronze, silver, sales promotions, and complete the rest of the task, all the 3 tasks there. Now this is all, we are talking about repair and rerun, and we are talking about for each and a lot of other things. Now, many a time, it usually happens that we have a huge DAG. Like right now, Databricks allows 1,000 tasks. Very recently, we are supporting 1,000 tasks. But having 1,000 tasks is probably a huge maintenance and management issue. Now, what you would like to do in such cases is probably modularize those jobs into multiple sub-jobs and then trigger them. Now, that's where, again, one more beauty feature in Databricks. Now, let me start one simple job here. Run job, and I will choose one of the notebooks which I have for whatever task 1, and specify some notebook. Yeah, serverless, and then data ingestion. I created the task. Now, as a second task, instead of creating another task, what I would like to do is use run job. This is the run job task, and I will use the same repair and rerun task which we just now ran. That's the task. So I specified that, and I am already having all the values, and click on create task, and I run the job. So this way you can have a huge DAG could also be decomposed into multiple sub-jobs, and you can orchestrate that as well, like in a simple way. And this could, I'm just showcasing one task and one job, but you can have multiple job types also into this, and you can create how many ever required. So that's about run job. And my final simple demo is on utilizing code for triggering jobs. So it's most of the best practices which Anthony was talking about are with DAGs. So essentially, you create notebooks. For example, in this case, I have a notebook.py, which is explicitly I'm calling out as Databricks notebook source. And then I also have some Python code, pure Python script, and there is SQL query also. So there is a lot of things which are happening here. And what I'm trying to do here is I'm using job config. This is all DAGs. With a job config, I created a complete YAML file which lists the tasks. Like I have ingestion task, which is nothing but notebook.py. I'm calling it out here. And then there is a Spark Python task, which is my main.py. And finally, there is another SQL task. So I have all this. Now, the it's usually a lot of people would like to use their local workspace, or they would like to use DABs to push from dev to test to QA to prod. So for all that, you could potentially use DABs. And it's very simple. Like in this case, I'm doing, I have the entire code here. Now I have the code here, and also I have, I just do the authentication with Databricks. And when I do that, it's already authenticated. So in my case, I wouldn't need to do anything. Now immediately I will do bundle sync. I mean, whatever code I have right now, it will get synced into Databricks platform, and it will get deployed, and a job also is created, all with the help of the job config and the Databricks YAML here. Now the YAML has the dev, which is the workspace which I'm using right now. The moment I press enter here, it will kickstart, it will create a job, and it will also show me if there are multiple jobs, it will help me, it will give a helpful prompt to choose which of the jobs you want to run. In my specific case, as you can see, there is only a single job in the job config. There is a single job here, my data processing job. So once it loads, yeah, you can see my data processing job, orchestration DAGs, and I will just press enter here. It should start the job, and it will also help you, give you a run URL. Now let me take this URL, go to the UI platform, and then press enter. Here is where you see my job actually running, and it's complete DAG. And you can also look at the YAML code right in the platform. It's taking a bit of time, so let me go to a different job to showcase. So I have the complete code here. This is YAML. This is nothing but exactly the same thing which I did from my local environment. In this, now it is directly in the platform. And you can also look at JSON, Python, and other variants also, which we were discussing earlier. So this is how you do, you deploy code, you run code using DABs. So the job is running, as I mentioned, an ingestion task, and then analysis task with a Python source, and analysis task as a SQL notebook. So the job is running. It should complete in a couple of minutes. So we'll hopefully, yeah. So these are a couple of things I wanted to show today.
Yeah, absolutely. Thank you. So we have a bit of time left. So I just want to do some sort of final housekeeping before we get to questions. So just with three main takeaways. Firstly and secondly, we have the real value of data triggers. They empower collaboration and independence between your data teams. Again, as you scale, your data teams will scale with you, and you need to make sure that you establish a mesh architecture that is able to support this. Data triggers is able to provide the platform for that. Use data triggers primarily to run jobs only when the data is actually ready. And then finally, you can really combine data triggers and control flow to build very sophisticated, very robust data meshes on top of Lakeflow Jobs. So for more presentations and to learn more about not just Lakeflow Jobs, but the other side of Lakeflow, definitely we would recommend these. As well as on the bottom, make sure not to miss the Lakeflow keynote, which is tomorrow. It's a really cool demo. And yeah, final thing, complete your surveys. And yeah, now we still have some time for questions. And if there's any flow over, we can go outside.